Hello everyone, welcome to Chemitarian. In today's class, we are going to discuss about reaction mechanism. So first thing, what is the chemical reaction? So chemical reaction is a process where old bonds are break and new bonds are formed. So chemical reaction is the process where old bonds are break and new bonds are formed. So firstly, we have two things in a chemical reaction. First thing is reactants and the other thing is product. So in any chemical process, reactant converted into product. But in a organic reaction, we have some specific things, just like first thing is substrate. Substrate is a substrate. Substrate is a chemical substance which is our reactant, and second reactant is attacking reagent. So are substrate and attacking reagent are reactant which converted into intermediate, and the intermediate converted into products and byproducts. So in organic reaction the reactants are two types. First are substrate and second one is attacking reagent. And then attacking reagent attack on substrate and they form intermediate, and intermediate converted into products and byproducts. So we have to understand what is the substrate, what is the attacking reagent, and what is the intermediate. So start from substrates. So substrate are the organic compound which provide base for the reaction. Okay, so substrate are the organic compound which provide the base of the reaction, and the substrate converted into product. Okay, so mainly the substrate is the organic compound in organic reaction which provide the base of the reaction. Okay, so substrate is organic compound, and you know that organic compound consists of covalent bond, which means in substrate there should be covalent bond. Okay, so suppose there is a substrate which is CH3CH3. Okay, so first thing we have to break the bond. Okay, and it is called as bond cleavage. Okay, the breaking of bond is called as bond cleavage or bond fission. So in organic reaction, first thing, when attacking reagent attack on substrate, the substrate goes under bond cleavage. Okay, there is two type of bond cleavage. The first one is homolytic. First one is homolytic bond cleavage, and second one is heterolytic bond cleavage. So first thing we have to understand what is homolytic bond cleavage. Okay, suppose there is two element A and element B, attached towards each other by covalent bond. Okay, if if the electronegation differences between A atom and B atom, if electronegation differences between A atom and B atom is less than 0.7, then both the element contain their sharing of electron, both the element contain their sharing of electron, and and in which equal in which homolytic bond cleavage equal distribution of electrons take place. Okay, equal distribution of electron take place. As you know, in covalent bond there is the sharing of one electron by A atom and one electron by B atom, and then they form A and B a sigma bond. Okay, so in the homolytic bond fission, when the electronegation difference is less than 0, the bond break in between, and both the atom A and B take their electron and form our first intermediate which is called as free radical. So in homolytic bond cleavage, free radical form. Okay. So suppose there is an organic compound which is CH4. As you know, this is the methane. Okay. So there is 4 covalent bond in between carbon and hydrogen. The first one, the second one, the third one, and the fourth one. So we have to break the bond in between carbon and hydrogen. Okay, so in this bond, one electron is from hydrogen and one electron is from carbon. Okay, so in the presence of sunlight, because the electron activity of carbon is 2.4 and the electron activity of hydrogen is 2.3, 2.1, and the electron activity differences is 0.3, which is less than 0.7. So this bond undergoes homolytic bond cleavage. Okay, so bond break and C hydrogen, 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 and carbon contain its electron and hydrogen contain its electron. So it is called as carbon free radical, and it is a intermediate. Intermediate. So when any substrate goes under homolytic bond cleavage, then intermediate carbon free radical is formed. Okay, so let's count the electron of carbon free radical. So there is one covalent bond which contain 2 electrons, that is the second covalent bond, and that is the third covalent bond. Three covalent bond contain 6 electrons, and this one the seventh electron. So carbon free radical contains 7 electrons, which means 3 pair of electron and one unpaired electron. When any molecule contain any unpaired electron, it is paramagnetic. It is paramagnetic in nature. Paramagnetic means attraction towards magnetic field. Okay, so carbon free radical intermediate are paramagnetic in nature because it contain one unpaired electron. Okay, fine. Okay, and the second condition, the second bond fission is heterolytic bond cleavage or heterolytic bond fission. The bond cleavage in which unequal unequal distribution of electron take place. Okay, suppose there is a bond between A atom and B atom, and B atom is more electronegative than A atom. Okay, so B atom took the electron from the covalent bond. Okay, then both the electron goes toward B atom, and there is two type of ion form. First ion is A plus and second ion is B minus. Okay, so in heterolytic bond cleavage, there is positive and negative ion or cation and anion is formed. Okay, so in this type of bond cleavage, we have to understand the electron activity differences between two atoms should be greater than 0.7. Okay, suppose we took an example chloromethane CH3Cl. Okay, so when we talk about CH3Cl, chlorine is more electronegative than carbon. Okay, so chlorine attract these electron, this sharing electron toward itself, and after the bond cleavage, CH3 plus and chlorine minus form. Okay, or CCl bond, both the electron goes towards Cl and Cl minus and C plus form. When carbon contain positive charge, it called carbocation, which means intermediate carbocation formed by the heterolytic bond cleavage. Okay, and this is the chloride ion. Okay, after that we have to count the electrons. Okay, so in CH3, in carbocation or methyl carbocation, in CH3 there is 3 covalent bond between carbon and hydrogen, and carbon contain positive charge. Positive charge means less electron. Okay, so one covalent bond contain 1 electron, 2 covalent bond contain 2, and 3 covalent bond contain 3. 3 pair of electron, which means carbocation contains 6 electron. 6 means 3 paired of electron. There is no unpaired electron. So the molecule which contain zero unpaired electron, which does not contain any unpaired electron, they are diamagnetic. Diamagnetic in nature. Diamagnetic means these are not attracted or repelled by magnetic field. Okay, so carbocation formed by heterolytic bond cleavage are diamagnetic in nature. Then suppose carbon attached to a element, carbon attached to a element A. Okay, and A is electropositive element or less electronegative element than carbon. Okay, then both the electron of sharing goes toward carbon and CH3 minus and A plus are formed. Okay, so let's talk about CH3 minus. It is called as, when carbon contain negative charge, it called as carbanion. Okay, and it's called carbanion. Okay, and carbanion contain 3 covalent bond and 1 negative charge, which means 3 covalent bond 6 electron and 1 negative charge contain 2 electron, total 8 electron. Okay, which means 4 paired of electron, and it is also contain 0 unpaired electron. So carbanion also in a diamagnetic in nature. Diamagnetic in nature. Okay, so now we have to summarize things. So first thing, the organic compound which called as substrate goes under bond fission and form intermediate. Then intermediate can be carbon free radical, carbon free radical can be carbocation, carbocation or can be carbanion. Intermediate can be carbon free radical, carbocation and carbanion. Carbon free radical represented by carbon and this is the electron. Carbocation represented by carbon and with positive charge, and carbanion react with represented by carbon and negative charge. Carbocation contains 7 electron, it contains 6 electron, it contains 8 electron. It has incomplete octet. It has also incomplete octet and it has complete octet. Octet means 8 electron. So carbanion has complete octet. Okay. Further, it is paramagnetic in nature, and both the carbocation and carbanion is diamagnetic in nature. Okay. Carbon free radical formed by homolytic bond fission, but carbocation and carbanion formed by heterolytic bond fission. Okay, so first thing, in any organic chemical reaction, substrate goes under bond fission and give intermediate either carbon free radical or carbocation or carbanion. Okay, second thing, in a organic reaction we have attacking reagent. So second thing, we have a attacking reagent. Attacking reagent are the substance which attack on substrate for the bond fission. Okay, it could be organic compound or inorganic compound. Okay, it could be organic compound or inorganic compound. Okay, so there is two type of attacking reagent. First is electrophile and other one is nucleophile. There is two type of attacking reagent. First is electrophile and second one is nucleophile. Okay, so let's talk about electrophile. Electro means electron, phile means loving. So those molecule or ions which are electron loving in nature are called as electrophile. Okay, which are electron loving in nature are called electrophile. But those molecule which are nucleus loving are called nucleophile. ठीक है, they are deficient in electron, they are rich in electron. Okay, so electrophile could be a positive charge or cation or could be a neutral molecule. Okay, positive charge such as H plus, such as NO plus, such as NO2 plus, such as X plus, such as R plus. Okay, these molecule or ion require the electron. Okay, so they are electrophile. Neutral such as all the Lewis acids. Okay, for example BF3, for example AlCl3, for example SO2. They are neutral electrophiles. But when we are talk about nucleophiles, so nucleophile means molecules or ions which are electron rich and they are nucleus loving. Okay, suppose we are talk about nucleophile, so we have three types, three or four kind of nucleophiles. First kind of negative charge or anions. Okay, as Cl minus, as OH minus, as OR minus, etc. Okay, second type of nucleophile is neutral molecule with lone pair. Okay, suppose NH3. NH3 has one lone pair. H2O have two lone pair. So they are also act as nucleophile. Okay, and third type is pi bond. Pi bond also called as electron rich molecule. So the compound contain pi bond also act as nucleophile. The compound containing pi bond also act as nucleophile. Except these, we have ambidentate nucleophile. Ambi means both. Okay, so the molecule in which two atom act as electron donor are called ambidentate nucleophile. Okay, suppose we are talking about NH2OH. Okay, so nitrogen also have a lone pair and oxygen have a two lone pair. Okay, so in this molecule both nitrogen and oxygen can act as nucleophile. So this is called as ambidentate nucleophile. Okay, so this is the first part of reaction mechanism, in which we only study about substrate and attacking reagent and little bit about intermediate. Okay, after that we have to discuss about the type of chemical reactions. Okay, the type of organic chemical reaction, types of organic chemical reaction, but we will discuss it in a other video. Thank you so much for watching. Please like, share and subscribe.